does not mean the same symbolism in this case as what we use for what? When do we use the dot, dot, dot? Augmented. So how could I tell this isn't augmented?
It's the
Yeah, I don't just have one row. I have, I'm sorry, one column. I have two columns over here. So I've got the identity matrix. So notice, matrix A is A, B, C, D. The identity matrix is 2 by 2 is 1, 0, 0, 1. And I'm going to now take this and put it into reduced row echelon form. This is, I really like this problem because it forces you to be able to walk through the process conceptually because there's no numbers here. It does get a little bit messy, and so we'll talk about that as well. All right, so here we go. I need a 1 up here, so I multiply by 1 over A. And you can see the result.
I'm confused what the dot 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 means. What is that?
That means I started with the A matrix, and on the right I have the identity matrix.
You can't write two separate matrices.
Why do you want to change what we do?
I don't know, I just don't
Okay.
understand what it means.
It means that I wrote a matrix, and in the matrix it was both the matrix A and its inverse. Just like we did before, but it didn't have the same impact as when we wrote this. But B was our, remember? B was our constant matrix. Well, here it's A, and B, in this case, is really our identity matrix. So it's just representing that I have two separate matrices that I'm putting together. All right, so we're down to here. Now, I need to get rid of the C. Opposite of C times row 1 and add it to row 2. You got to be careful. It gets a little bit messy. You can see that what I did over here was I showed the work of how I found this value right here. Okay, so now we should be down to the green matrix. So we're down to the green matrix. What do I need to do now? I need to make this a what? A 1. So I make that a 1 by multiplying that whole row by its reciprocal. That looks like a party. So we multiply this by A over AD minus BC, and we get 1 here, we get minus C over AD minus BC, and we get A over AD minus BC. AD. So tell me about the bottom row.
The left side looks good, the right side looks
Exactly. But aren't I finished with the bottom row?
Yeah,
How do I know?
because you have 0.
I got 0 and 1. Am I finished with the top row? No, what do you need?
The 0.
I need a 0 right here, correct? So, last step. I'm going to multiply this by the opposite of B over A and add it to this. So, the stuff here in pink was all stuff I could do without any computation. The work is what's in black. So, how do I get this? Let's see, I think I did the work right over here. Oh. Let's see here. Why am I feeling a little lost? Oh, there it is. When I multiply this times this, I get BC over A times this, plus 1 over A. So this times this, add it to this. And you do it off to the side, because there's no way I'm going to do that in my head. Now, I know what it's supposed to be, but there's no way I could actually see it quickly that way. Common denominator, BC simplifies. I'm left with AD over this. A simplified, and I get D over AD minus BC. The last one is actually pretty easy. This is the only one that really is the work. Because what happens when I do it times the next one? B over A times this last term, what happens?
The A goes away.
Because I didn't show any work. The A's will simplify, and what am I left with?
Negative.
Negative B over AD minus BC. So what did I just find?
The inverse.
I just found the inverse. So this right here, oh, that was bad. It was that color that I used was such a poor choice. Can't even see it hardly. There's my inverse. Well, what's this over here? The identity. Very good. Very good. So what I started with here was A with the identity over here. I do my elementary row operations, and what do I end up with? The identity and A inverse. So tell me, when you're going through this process, what would it look like for this not to have an inverse? What would have to happen in order for me to go through the elementary row operations and for this matrix to not have an inverse? And by the way, when I'm asking that question, I'm kind of, there's implications there, aren't there? What am I implying?
No solution.
Close, but what am I implying when I'm with my phrase, with my statement, with my question?
Sometimes doesn't work.
Yeah, sometimes it's possible I don't have an inverse. So then the question becomes, what would happen, you know, with the mathematics here, not the concept, but with the actual computation that would show me, oh, there's no inverse here. Well, what am I supposed to end up with? What am I supposed to end up? When do I know I'm done?
When you get the left side to be reduced direction.
Even more important, has to be the identity. Because 0, 0, 1 would be reduced to echelon form. Problem is I don't have the identity here. If your result does not give you the identity here, meaning that's not 1, then there is no inverse for that.
So if that's a 0.
Yep.
Okay.
So if I ended up with 1, 0, and then this was a 0, I don't have an inverse. We say that it is not invertible. It is not invertible. So here we go. Terminology. Terminology. I want to talk about what's called the determinant. I'm going to just talk about a 2x2 determinant. We'll do the hard ones later. Okay? A 2x2 determinant is found very simply. Do you see the notation for a determinant? What's the notation? Absolute value. What do we get when we take the absolute value of something? Distance. What's the absolute value of a vector? Okay, but it is a what? It's a number. You know, because you're in Vectorville and you didn't end up with a vector when you did the absolute value. Well, interesting enough, when you take the determinant of a matrix, which has a dimension or order other than 1 by 1, it's going to give you a number back, which is like a scalar. It's just a number. How do I find the number? A 2x2 is very simple. You take the main diagonal, A times D, and subtract the product of the other diagonal, B times C. So AD minus BC gives me the determinant. Well, now look over there and see where AD minus BC is.
Is it always like that then?
For a 2x2. You see what we're really saying here? So I don't, oh, there it is, thank you. I knew I had to have written it down here somewhere. So the inverse of A is actually equal to 1 over its determinant times. Now notice, what did we start out with for A? It was A, B, C, D, correct? Notice what happened. Describe what took place here. Look at A, look at what I got for the inverse here,
A and B.
and tell me, whoa. I'm sorry, say that again?
A and B switched, and B and C got, they're now negative.
Okay, so the signs changed, and these values switched. I usually say, you switch the values for A and D, and for B and C, you leave them alone, but switch the sign. Change the sign. So they both have a switch, it's just that the B and C stay there. And all they do is you take the opposite of the sign that they were. So, here we go. If this is my B, I should be able to find two things there, correct? I should be able to find both its inverse, if it exists, and what else do we need to find in order to do that? It's determinant. Go ahead. Find the determinant, and then find the inverse of B. This should be what you got. I do think it's kind of nice to write it like this before you just dive in. Again, careless error issues is the worst thing with matrices. Usually the students do very well on this test, but I think partly due to the fact that they didn't do as well on the last one, so they actually apply themselves in a little bit more purposeful way. And I also think this is more accessible. I think this material is a little bit easier to work with. True? I mean, it's definitely been a little easier than what we did in Vectorville. Plus, we also came off 2 weeks of Christmas, and then just, you know, it's kind of like throwing you in a pool when it's really 65 degrees in the pool. So, I mean, not that that's not good, don't get me wrong, it will wake you up. Any of you guys swim early in the morning here? How warm is the water?
The janitor says 80, but the janitor also lies.
I noticed that when I talk to him, he lies to me, right to my face. Liar.
It's not 80 in that pool.
Is it warmer?
No.
You know, the problem is when you get out, not when you're in.
You
And-
get in, it's
Yeah, when you
bad,
get
and then
in,
you
it
get used
feels
to it,
warm.
and then you get out, and it's even worse.
I know. If they would let you swim underwater with a snorkel, it would be better, because then you would have
It doesn't help.
no body parts exposed.
They do,
No,
it's
but
not
then
doesn't
your
help.
mouth's gonna be really cold and dry.
They give it.
So really, there is no cure for this.
There is.
And also when you swim, you're
So you
under
really need on the
water.
top of your snorkel a heater
You know what we really
that
need?
warms the air.
You know what we really need is to not go.
Really, the
Yeah.
only cause of all learning is don't swim in the
That would be the
morning.
saddest thing that we ever did built, I will be honest with you. Oaks Christian's building an indoors pool so they can swim early in the morning when it's cold.
Actually, indoor pools suck.
Yes, but that's where it snows.
No, here.
Why?
I played a game at school in the pool.
Yeah, it's weird, isn't it?
It was so
Weird.
weird.
They
And
smell.
They had
Smell
music
like
underwater.
Yes.
They had speakers
That-
underwater.
I want one of those
That
pools.
was awesome.
Could you actually understand it?
Yeah, you can hear it. You can't hear it when you're above. When you're under, you
That's
can hear
so
it.
fantastic. We're building one.
We're building one. I would just be happy if they put a above ground spa, huge one,
Like
for the faculty.
So an indoor
Okay,
pool is too much, but
mostly
it's
because if the faculty members go in there, the last thing kids want to do is go, I ain't going up there. I'm sorry, I was going to say something.